This is the new computer industry. Software is no longer programmed just by computer engineers. Software is programmed by computer engineers working with AI supercomputers. We have now reached the tipping point of accelerated computing. We have now reached the tipping point of generative AI. And we are so excited to be in full volume production of the H100. This is going to touch literally every single industry. Let's take a look at how H100 is produced. $35,000 components on that system board. 8 Hopper GPUs. Let me show it to you. Whoosh. All right, this, I would lift this, but I still have the rest of the keynote I would like to give. This is 60 pounds, 65 pounds. It takes robots to lift it, of course, and it takes robots to insert it because the insertion pressure is so high and has to be so perfect. This computer is $200,000. And as you know, it replaces an entire room of other computers. It's the world's single most expensive computer that you can say, the more you buy, the more you save. This is what a compute tray looks like. Even this is incredibly heavy. See that? So this is the brand new H100 with the world's first computer that has a transformer engine in it. The performance is utterly incredible. There are 2 fundamental transitions happening in the computer industry today. All of you are deep within it and you feel it. There are 2 fundamental trends. The first trend is because CPU scaling has ended. The ability to get 10 times more performance every 5 years has ended. The ability to get 10 times more performance every 5 years at the same cost is the reason why computers are so fast today. That trend has ended. It happened at exactly the time when a new way of doing software was discovered, deep learning. These 2 events came together and is driving computing today. Accelerated computing and generative AI. This way of doing software, this way of doing computation, is a reinvention from the ground up, and it's not easy. Accelerated computing has taken us nearly 3 decades to accomplish. Well, this is how accelerated computing works. This is accelerated computing used for large language models, basically the core of generative AI. This example is a $10 million server, and so $10 million gets you nearly 1,000 CPU servers, and to process this large language model takes 11 gigawatt hours. 11 gigawatt hours. Okay, and this is what happens when you accelerate this workload with accelerated computing. And so with $10 million, for a $10 million server, you buy 48 GPU servers. It's the reason why people say that GPU servers are so expensive. Remember, people say GPU servers are so expensive. However, the GPU server is no longer the computer. The computer is the data center. Your goal is to build the most cost-effective data center, not build the most cost-effective server. Back in the old days when the computer was the server, that would be a reasonable thing to do. But today, the computer is the data center. So for $10 million, you buy 48 GPU servers. It only consumes 3.2 gigawatt hours and 44 times the performance. Let me just show it to you one more time. This is before, and this is after, and this is We want dense computers, not big ones. We want dense computers, fast computers, not big ones. Let me show you something else. This is my favorite. If your goal is to get the work done, and this is the work you want to get done, ISO work, okay? This is ISO work. All right, look at this. Look at this. Look at this. Before, after. You've heard me talk about this for so many years. In fact, every single time you saw me, I've been talking to you about accelerated computing. And now, why is it that finally it's the tipping point? Because we have now addressed so many different domains of science, so many industries, and in data processing, in deep learning, classical machine learning, so many different ways for us to deploy software, from the cloud to enterprise to supercomputing to the edge. So many different configurations of GPUs, from our HGX versions to our Omniverse versions to our cloud GPU and graphics versions, so many different versions. Now, the utilization is incredibly high. The utilization of Nvidia GPU is so high, almost every single cloud is overextended. Almost every single data center is overextended. There are so many different applications using it. So we have now reached the tipping point of accelerated computing. We have now reached the tipping point of generative AI. People thought that GPUs would just be GPUs. They were completely wrong. We dedicated ourselves to reinventing the GPU so that it's incredibly good at tensor processing. And then all of the algorithms and engines that sit on top of these computers, we call Nvidia AI. The only AI operating system in the world that takes data processing, from data processing to training to optimization to deployment and inference. End-to-end deep learning processing. It is the engine of AI today. We connected GPUs to other GPUs called NVLink, build one giant GPU, and we connected those GPUs together using InfiniBand into larger scale computers. That ability for us to drive the processor and extend the scale of computing made it possible for the AI research organization, the community, to advance AI at an incredible rate. So every 2 years, we take giant leaps forward, and I'm expecting the next leap to be giant as well. This is the new computer industry. Software is no longer programmed just by computer engineers. Software is programmed by computer engineers working with AI supercomputers. These AI supercomputers are a new type of factory. It is very logical that a car industry has factories. They build things that you can see, cars. It is very logical that computer industry has computer factories. You build things that you can see, computers. In the future, every single major company will also have AI factories, and you will build and produce your company's intelligence. And it's a very sensible thing. We are intelligence producers already. It's just that the intelligence producers, the intelligence are people. In the future, we will be intelligence producers, artificial intelligence producers. And every single company will have factories. And the factories will be built this way, using accelerated computing and artificial intelligence. We accelerated computer graphics by 1,000 times in 5 years. Moore's law is probably currently running at about 2 times. 1,000 times in 5 years. 1,000 times in 5 years is 1,000,000 times in 10. We're doing the same thing in artificial intelligence. Now, the question is, what can you do when your computer is 1,000,000 times faster? What would you do if your computer was 1,000,000 times faster? Well, it turns out that we can now apply the instrument of our industry to so many different fields that were impossible before. This is the reason why everybody is so excited. There's no question that we're in a new computing era. There's just absolutely no question about it. Every single computing era, you could do different things that weren't possible before. And artificial intelligence certainly qualifies. This particular computing era is special in several ways. One, it is able to understand information of more than just text and numbers. It can now understand multimodality, which is the reason why this computing revolution can impact every industry. Every industry. Two, because this computer doesn't care how you program it. It will try to understand what you mean. because it has this incredible large language model capability. And so the programming barrier is incredibly low. We have closed the digital divide. Everyone is a programmer now. You just have to say something to the computer. Third, this computer, not only is it able to do amazing things for the future, it can do amazing things for every single application of the previous era, which is the reason why all of these APIs are being connected into Windows applications here and there, and browsers, and PowerPoint, and Word. Every application that exists will be better because of AI. You don't have to just AI. This generation, this computing era, does not need new applications. It can succeed with old applications, and it's going to have new applications. The rate of progress, because it's so easy to use, is the reason why it's growing so fast. This is going to touch literally every single industry. And at the core, just as with every single computing era, it needs a new computing approach. The last several years, I've been talking to you about the new type of processor we've been creating. And this is the reason we've been creating it. Ladies and gentlemen, Grace Hopper is now in full production. This is Grace Hopper. Nearly 200 billion transistors in this computer. Oh, 蛮重的. Look at this. This is Grace Hopper. This processor is really quite amazing. There are several characteristics about it. This is the world's first accelerated computing processor that also has a giant memory. It has almost 600 gigabytes of memory that's coherent between the CPU and the GPU. And so the GPU can reference the memory, the CPU can reference the memory, and any unnecessary copying back and forth could be avoided. The amazing amount of high-speed memory lets the GPU work on very, very large data sets. This is a computer. This is not a chip. Practically the entire computer is on here. Uses low-power DDR memory, just like your cell phone, except this has been optimized and designed for high-resilience data center applications. So let me show you what we're going to do. So the first thing is, of course, we have the Grace Hopper superchip. Put that into a computer. The second thing that we're going to do is we're going to connect 8 of these together using NVLink. This is an NVLink switch. So 8 of this connect into 3 switch trays into 8 Grace Hopper pod. These 8 Grace Hopper pods, each one of the Grace Hoppers are connected to the other Grace Hopper at 900 gigabytes per second. 8 of them connected together as a pod, and then we connect 32 of them together with another layer of switches. And in order to build this, 256 Grace Hopper superchips connected into 1 exaflops. 1 exaflops. You know that countries and nations have been working on exaflops computing and just recently achieved it. 256 Grace Hoppers for deep learning is 1 exaflop transformer engine, and it gives us 144 terabytes of memory that every GPU can see. This is not 144 terabytes distributed. This is 144 terabytes connected. Why don't we take a look at what it really looks like? Play, please. This is 150 miles of cables, fiber optic cables, 2,000 fans, 70,000 cubic feet per minute. It probably recycles the air in this entire room in a couple of minutes. 40,000 pounds, 4 elephants. 1 GPU. If I can get up on here This is actual size. So this is our brand new Grace Hopper AI supercomputer. It is one giant GPU, utterly incredible. We're building it now, and we're so excited that Google Cloud, Meta, and Microsoft will be the first companies in the world to have access, and they will be doing exploratory research on the pioneering front, the boundaries of artificial intelligence with us. So this is the DGX GH200. It is one giant GPU. Okay? I just talked about how we are going to extend the frontier of AI. Data centers all over the world, and all of them over the next decade will be recycled and re-engineered into accelerated data centers and generative AI capable data centers. But there are so many different applications in so many different areas: scientific computing, data processing, cloud and video and graphics, generative AI for enterprise, and of course the edge. Each one of these applications have different configurations of servers, different focus of applications, different deployment methods, and so security is different, operating system is different, how it's managed is different. Well, this is just an enormous number of configurations. And so today we're announcing, in partnership with so many companies here in Taiwan, the Nvidia MGX. It's an open modular server design specification, and it's designed for accelerated computing. Most of the servers today are designed for general purpose computing. The mechanical, thermal, and electrical is insufficient for a very highly dense computing system. Accelerated computers take, as you know, many servers and compress it into one. You save a lot of money, you save a lot of floor space, but the architecture is different. And we designed it so that it's multi-generation standardized, so that once you make an investment, our next generation GPUs and next generation CPUs and next generation DPUs will continue to easily configure into it so that we can have best time to market and best preservation of our investment. Different data centers have different requirements, and we've made this modular and flexible so that it could address all of these different domains. Now, this is the basic chassis. Let's take a look at some of the other things you could do with it. This is the Omniverse OVX server. It has x86, 4 L40s, BlueField-3, 2 CX7, 6 PCI Express slots. This is the Grace Omniverse server. Grace, same 4 L40s, BF3, BlueField-3, and 2 CX7s. Okay, this is the Grace Cloud Graphics server. This is the Hopper NVLink Generative AI Inference server. And of course, Grace Hopper liquid cooled, okay, for very dense servers. And then this one is our dense general purpose Grace superchip server. This is just CPU, and it has the ability to accommodate 4 Grace CPUs or 2 Grace superchips. Enormous amounts of performance. In ISO performance, Grace only consumes 580 watts for the whole server, versus the latest generation CPU servers, x86 servers, 1,090 watts. It's basically half the power at the same performance. Or another way of saying, at the same power, if your data center is power constrained, you get twice the performance. Most data centers today are power limited, and so this is really a terrific capability. We're going to expand AI into a new territory. If you look at the world's data centers, the data center is now the computer, and the network defines what that data center does. Largely, there are 2 types of data centers today. There's the data center that's used for hyperscale, where you have application workloads of all different kinds. The number of GPUs you connect to it is relatively low. The number of tenants is very high. The workloads are loosely coupled. And you have another type of data center. They're like supercomputing data centers, AI supercomputers, where the workloads are tightly coupled. The number of tenants, far fewer, and sometimes just one. Its purpose is high throughput on very large computing problems. And so supercomputing centers and AI supercomputers and the world's cloud, hyperscale cloud, are very different in nature. The ability for Ethernet to interconnect components of almost from anywhere is the reason why the world's internet was created. If it required too much coordination, how could we have built today's internet? So Ethernet's profound contribution is this lossy capability, its resilient capability, and because so, it basically can connect almost anything together. However, a supercomputing data center can't afford that. You can't interconnect random things together because that billion-dollar supercomputer, the difference between 95% networking throughput achieved versus 50% is effectively $500 million. Now, it's really important to realize that in a high-performance computing application, every single GPU must finish their job so that the application can move on. In many cases where you do all reductions, you have to wait until the results of every single one. So if one node takes too long, everybody gets held back. The question is, how do we introduce a new type of Ethernet that's, of course, backwards compatible with everything, but is engineered in a way that achieves the type of capabilities that we can bring AI workloads to the world's any data center? First, adaptive routing. Adaptive routing basically says, based on the traffic that is going through your data center, depending on which one of the ports of that switch is over-congested, it will tell BlueField 3 and it will send it to another port. BlueField 3 on the other end would reassemble it and present the data to the GPU without any CPU intervention. Second, congestion control. Congestion control, it is possible for certain different ports to become heavily congested, in which case each switch will see how the network is performing and communicate to the senders, please don't send any more data right away because you're congesting the network. That congestion control requires basically an overriding system, which includes software, the switch, working with all of the endpoints to overall manage the congestion or the traffic and the throughput of the data center. This capability is going to increase Ethernet's overall performance dramatically. Now, one of the things that very few people realize is that today, there's only one software stack that is enterprise secure and enterprise grade. That software stack is CPU. And the reason for that is because in order to be enterprise grade, it has to be enterprise secure, it has to be enterprise managed, and enterprise supported. Over 4,000 software packages is what it takes for people to use accelerated computing today in data processing, in training, in optimization, all the way to inference. So for the very first time, we are taking all of that software and we're going to maintain it and manage it like Red Hat does for Linux. Nvidia AI Enterprise will do it for all of Nvidia's libraries. Now, enterprise can finally have an enterprise-grade and enterprise-secure software stack. This is such a big deal. Otherwise, even though the promise of accelerated computing is possible for many researchers and scientists, it's not available for enterprise companies. And so let's take a look at the benefit for them. This is a simple image processing application. If you were to do it on a CPU versus on a GPU running on enterprise, NVIDIA AI Enterprise, you're getting 31.8 images per minute, or basically 24 times the throughput, or you only pay 5% of the cost. This is really quite amazing. This is the benefit of accelerated computing in the cloud. But for many companies, enterprises, it's simply not possible unless you have this stack. NVIDIA AI Enterprise is now fully integrated into AWS, Google Cloud, and Microsoft Azure and Oracle Cloud. It is also integrated into the world's machine learning operations pipeline. As I mentioned before, AI is a different type of workload, and this new type of software has a whole new software industry. And this software industry, 100% of them, we have now connected with NVIDIA AI Enterprise. I told you several things. I told you that we are going through two simultaneous computing industry transition, accelerated computing and generative AI. Two, this form of computing is not like the traditional general purpose computing. It is full stack. It is data center scale because the data center is the computer. And it is domain specific. For every domain that you want to go into, every industry you go into, you need to have the software stack. And if you have the software stack, then the utility, the utilization of your machine, the utilization of your computer will be high. So number two, it is full stack, data center scale, and domain specific. We are in full production of the engine of generative AI, and that is HGX H100. Meanwhile, this engine that's going to be used for AI factories will be scaled out using Grace Hopper, the engine that we created for the era of generative AI. We also took Grace Hopper, connected to 256-node NVLink, and created the largest GPU in the world, DGX GH200. We're trying to extend generative AI and accelerated computing in several different directions at the same time. Number one, we would like to, of course, extend it in the cloud so that every cloud data center can be an AI data center. Not just AI factories and hyperscale, but every hyperscale data center can now be a generative AI data center. And the way we do that is the Spectrum X. It takes 4 components to make Spectrum X possible. The switch, the Bluefield 3 NIC, the interconnects themselves, the cables are so important in high-speed communications, and the software stack that goes on top of it. We would like to extend generative AI to the world's enterprise. And there are so many different configurations of servers, and the way we're doing that with partnership with our Taiwanese ecosystem, the MGX modular accelerated computing systems. We put Nvidia in the cloud so that every enterprise in the world can engage us to create generative AI models and deploy it in an enterprise-grade, enterprise-secure way in every single cloud. I want to thank all of you for your partnership over the years. Thank you.